Hello everybody! In today's journey of porting Package Resolved, a game about collecting packages, to this little cheese slice, the Playdate, we're going to start looking into adding some of the more challenging bits of the game. Namely, focusing on obstacles today. Maybe a rolling background for Lucky, though I haven't prepared the artwork for that. So it will most likely just be obstacles today. See how everyone is... Okay, well let's just start, and so... I'm sure more folks will show up in the meantime. So you can see here, yeah, I kind of forgot to fill out the tree for today. Whoops. I have done all sorts of other fancy things, though, so that's something I will definitely need to cover as well. So, let's go ahead and take a look at what we're dealing with today. So first, let me put me into mini-me mode. Lovely. So going down our tree, we are in the Draw the Rest of the Owl stage, focusing on the core gameplay loop. Now, last week where we left off, we finished the... Well, that was already finished last week. We finished the timer part. So now we have a timer that properly works, where you have 60 seconds to collect as many boxes as you can. We don't do anything with that timer afterwards besides just halting the game, but later down the line we'll do something with that. As you could see here, I also did kind of dig a little bit into some state management, namely focusing on creating levels from a configuration file. And I mostly wanted to make sure that the library that I was using, or that I want to use to get this done, actually compiles for the Playdate. Since it's not always the case that you could just yoink a C library and plop it in and just expect it to work. Which, for the most part, that kind of was the case for the library we're using, which is cCuddle. I actually did have to change one of these. Yeah, I did have to change some logic in here, mostly the add in place and multiply in place, to take a specific type, since for some reason on the Playdate, the type definition for what an unsigned integer is not uint32t. So a little weird C-ism going on there, but nonetheless, we do have the library available at our disposal, so no need to worry about that. This is way later, though. I don't imagine we're going to get to this for a while. Meanwhile, I will show off a couple of other things that we have been kind of doing in the meantime. The first major one here, besides the cCuddle thing, is documentation. In the first couple of streams, we actually did write some documentation comments for a lot of the code that we were doing, especially in our reusable library here, which you can kind of see it actually is using an older style, which does need to be changed, but at least for all the files in source, for the header files, we now have proper documentation comments for everything. Just kind of explaining what things are, as well as what certain methods do, along with their parameters respectively. For this particular style, I've decided to go with the Doxygen approach, just because it looked a little bit cleaner, and I'm sure it's a bit more recognizable than, say, Xcode styling of documentation comments. So that is why we have that particular style of comments. But rest assured, everything in this SRC folder, all properly documented. So if you want to go and look at the source code yourself, at least you'll know what each of these methods are actually doing. Just so you're not lost. And just so I'm not lost, because I'm sure in a couple weeks I will forget what a certain method does, and I'll be like, what? Okay. And last night, I did spend some time just working on the artwork for... That's the wrong one. On the artwork for what our main obstacle today is, which is going to be the palette. We're not going to delve into the other one just yet, which is the wet floor sign slash wet areas, and that's mostly because that one does require a little bit more logic, and I'm not sure if we're ready to even delve into that. So we're going to start with a very simple one here. And I believe that covers most of the changes that I had made since the last time we met on stream here. Looking through here just to make sure. Yeah, cuddle. I think I may have updated the instructions here. Yeah, okay. So, not much. Mostly, all the major changes are just kind of behind the scenes that we'll eventually get to at some point. So, with that in mind, let's go ahead and take a look at what we're dealing with here. So, first off, I'm going to need to take all of this, move it way out, at least for now, because I want to make sure I have enough room for this. So let's take you, remove this connection. We're going to put you down here. So what are some things that we need to keep in mind for obstacles? Big thing we're going to need to check is collisions. That's going to be the major one. As well as triggering a game over state for these obstacles, and then I think the other major one is just, placing them accordingly. And I think what we may end up doing is we may need to end up changing some of the logic around behind the boxes to get this to be a bit more modular. I'm not sure, though. We'll have to play around with it and see what we can do. So this is kind of where we are at right now. So I guess let us begin and kind of revisit what we're looking at here once the project builds. Okay, there we go. Oh, that's right. That's the other thing that I forgot. I was playing around with custom fonts since the game doesn't use the Playdate's default fonts when you look at the version made in Godot. So I was playing around with using the actual proper font for the game, which seems to work pretty well as far as I'm concerned. So that won't be a problem. Make sure to unlock the device here. I'm going to use this as the controller. Yeah. So we do have a better, more pixelated font on the screen that actually looks really crisp. I was doing some minor UI work earlier, but I didn't actually get around to doing it. Now, I am kind of realizing maybe it's not a good idea to combine the boxes and the obstacles together in the same area, since we don't have a whole lot of boxes on the screen at a time. So we will probably have to create our own specific area for them, which is fine. So I will put the Playdate on the side there. And, so I guess what we will probably have to do is we're probably going to have to do some extra work on this. Thankfully, we don't have to worry about animation, so no frame cycles needed for that. So I guess probably the first thing is just getting them to draw on the screen, right? So thankfully, that's a very familiar process. We just take a bitmap and we're just going to say palette image like this. And then we just need to do something. Load box table. Fill boxes, reset elapsed time. So we'll put this after setup. So what we need to do is, trying to remember. I think we could just say palette image is load bitmap. Yeah, loads an image into the Playdate bundle at the specified path. That is ours. So it should be images palette. And then we just pass in PD if palette image is null. Now we're going to just report a system error. Couldn't load palette image. Return 0 there, because there's no point in continuing. Alright, and I think that's fine. Let the builder do its thing. Okay. So it's running, which means that we don't need to worry about that. Okay. Now the thing with this one is we want this to be a bit random-ish. So I don't know how we want to actually position these. I think what we'll say is that there's going to be a max of 2 of these, probably. Define palette count 2. So then we can say vec2f palette count. We don't need to worry about boxes collected or anything like that. So we'll be good. Loads the box image table into memory. So we're probably going to need to do our own fill boxes, now that I think about it. But for the thing, well, I guess we could just say, I mean, technically we could do this. Where are you defined again? Boxes C. Yeah, and then we can do things here. For why are you screaming? Oh, that's why. Not sure what's going on here. We probably extrapolated some logic. So we want to grab the position from this. So palettes at I. What are we doing? Exactly. Let's look at game loop C. Yeah, okay. So we're calling the graphics. Calling the graphics. PD. Graphics. Draw bitmap. And we just pass in a palette image followed by position.x, position.y. K bitmap unflipped. I don't know why it does that every time. I mean, this will probably keep it in the same spot, right? Yeah. Oh, you know what? I forgot to scale that up. Boo! Okay. I can fix this. Export as 200. You are saving directly into there. Palette already exists. Yeah, that's the point. Reconnection successful. Oh, that was a bit weird. Save. Okay. Switch back. Cool. We got palette on the screen. It's sticky, but it's drawn. So that's something. So I guess we can also do that one check that we have, right? Because realistically, it's the same logic as collecting a box, except you don't pick up the box, right? Distance to player is vec2f distance sprite position at position if distance to player is less than 32, then I don't think we need to do the rest of the logic, no? Return 0. Oh, you know what? We could say time remaining is 0. Return 0. I think. Oh, hold on. I need to... Yeah, use devices controller. Oh, it's confused. Oh, well, that didn't take long. Though, I think the distance is a little too powerful here. So, maybe let's do 16 instead? Not quite how I was anticipating, but that could also be just because of the way that this is being done. Yeah. Okay. How about 24? Does that load? Not quite triggering either. Okay, so we are definitely going to need to do some more advanced collision logic. Okay. Do we have anything for getting a rectangle? Actually, I think we have a thing for sprites. Yeah, okay. Okay. So palettes need to be a bit more complex than this. So, yeah, we're going to need to be a bit more fancy with this, I think. Palette.h if and palette h define palette h and if. Okay. Just copy those for now. Type def struct palette. So what we're going to need then is an LCD sprite, and then a vec2f position, like this. Because we need the actual sprite for the rectangle. And then we're going to track the position for when we're placing it, I think. Yeah, okay. Okay. Yeah, brain. Let's check to see what's going on in chat real quick while I am at it. Hey, what's up, Aton? No one else. Okay. Oh, boy. Let's go back and see what we can do here. I'll worry about adding comments later for this. Yeah. Okay. So I guess let's also make a thing for this. Palette, yeah, vec2f. Right, because we're going to want to put the position at where it's going to be. And then we're going to want to reference to the actual sprite, the actual image itself. And then we're going to want the Playdate API object to work with. Okay, let's create the palette.c. Okay. Oh, we're also going to need to include the thing, right? Yeah. Include palette.h. Okay, now before I do anything, we need to update our sources. src palette.c, like this, and then we need to update our completions. Just completions. Okie dokes. So that is at our disposal. Okie dokes. So, first thing we're going to need to do is to create a sprite.
Which I think we can do by just saying, oh, come on. Really? There we go. Sprite is imaged sprite vec2i size. Oh, okay. This wasn't something that I realized either. Const vec2i palette size is 3232 PD palette size, and then LCD bitmap image, and then I think we could just create the new palette, right? Like this. Sprite position, and then return palette generated. Yeah, okay. Fairly simple. So let's actually change this around then. So vector PD API include palette.h. Now what we're gonna need to do is we just need to change you to palettes. Yes. So this logic no longer works, which is to be expected. So let's make something to do that then. So my guess is we're probably going to need to take the same logic as the boxes. Yeah, so let's move you to the side. I'm going to collapse the sidebar so we can see what we're doing here. Minimap. Going to lower that a little bit. There we go. Fill palettes. So we're going to need the palette box, or the palette array. Int quantity vec2f bounds inset insets, I think, right? Yes. Okie dokes. So let's go back to palette.c so we can do this. Unknown type inset because we need... Where did you come from, first off? Include palette.h unknown type inset. Include vector h. Oh, we need the boxes. Because we didn't actually move that out into a common thing. Got it. That's a little silly. Include boxes.h. So hopefully that doesn't scream at me anymore. Uh-oh, 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 uh-oh. Incompatible pointer type. Well, I mean, that's to be expected. Let's comment that out. Okay. Okay, so that's no longer screaming at us. That's what I wanted to see. Okay, we're gonna have to shrink this one more time because I cannot see what we're doing here. Okay, fill palettes. So, y could be anything, so we don't need to worry about the step or anything. For int I is 0, I is less than quantity, I++, float x position is float rand float. Oh, we're gonna need all these other ones too. Not standard IO though. Rand max bounds dot x minus insets dot right. Okay? If x position is less than the left, x position is insets. Thank you. Okay. Yeah, and then we can just take the same logic for you, but make you y position. And bottom. Top. Top. Okay. Yes, vec2f position is x position, y position. Palettes. Oh, you know what? We're gonna need to pass in more information. I am realizing. So I will close you. LCD bitmap. Right. Because this is the actual image, so we need the image. But it is a reference. Okay. I'm just going to recopy the signature to help me out. Yeah, palette. Current is create. Uh-oh. Where's my type completions? Seriously? You're not even... I think the LSP crashed. Reload it. Lovely. Okay, there we go. Current is create palette at position image PD, and then we just say palettes at I is current. Like that, and then we should be A-okay. Cool. So I guess we will have to do this. Fill palettes to screen bounds walls palette image PD, and then now we're just going to uncomment that code, delete our existing logic. So then we just need to think about what we're doing here. What are we doing? Update player. Jump to the definition. Jump to implementations. No? No, you don't want me to do that because
I gotta do this. Okay, now, how did we do this? Get table bitmap. So these are the ones we need to call. I'm just going to get rid of that, because now we actually have more than one thing to do. So PD sprite update and draw sprites like that. So PD sprite set image sprite image. So that's going to be our palette. Is palettes at I. So sprite here is going to actually be current dot sprite. So image palette image. Yep. Current dot sprite to current dot position dot x. Current position dot y. Mark dirty. Current dot sprite. Hopefully we get palettes back on the screen. Cool. Cool, cool. That is what we wanted. So the palettes are back. I don't know why we're starting at the top there. We may need to adjust the offset on that. Oh, you know what? I think it's because we don't have a defined offset for the... Yeah, that's why. I'm gonna say Charlie height plus 8 for the top there. Because the boxes themselves are not actually affected by this change. It's only going to be the palettes. We just decided to spawn all the way down there, I guess. But also we're going to change that to 32 down there. Really weird positioning going on. That's okay. That's okay. It's not the end of the world. But at least they're drawing, which is the important part. But I guess the important thing here is we're going to need to do the same thing for the shifting, I think. So let's see how this is handled real quick. Threshold, index. Oh, because it redraws at the bottom. Okay, I think... Nah, we'll keep that. Fill palettes. That's what we want. And then the next thing we need is... Okay, this is gonna drive me bonkers. Why is this... Whatever. Let's see if we can get the collision set up here. So collision's enabled for the given sprite. Oh, do we not have that set up for both of these? We probably should. Okay, well, at least we can take the one for this one. Current dot sprite, or no, PD graphics set, not graphics, sprite collisions enabled for current dot sprite. That'll help. Right? No, we want to say set collisions enabled. Current dot sprite int flag. 1 is true, 0 is false. marks the area of the given sprite relative to its bounds to be checked for collisions. Okay, I have no idea what that means. So let's just see if we actually get a rectangle or if we're going to have to define that rectangle ourselves. I think there's a thing that we could do for that. Send bitmap, no. Show sprite collision recs. Okay, we got nothing. That's interesting. So then you take a set collide rect relative to its bounds. I don't know what that actually means, but we'll see. PD sprite set collision or set collide rect. Yes. Current dot sprite to a PD rect. PD rect collider is... What is this? Float XY with height. Oh, okay. So this should be 0, 0 palette size dot x palette size dot y, I think. And then we just pass in a collider. How does that look? Let's go. That is what we want. Cool beans. I probably want to cut the height a little bit, though, to give a little bit more leeway for the sake of the, for it visually looking okay. So, loss of precision used in a floating point context. Oh, these are... Okay, well that one we don't need to worry about. I think that'll handle the collisions just fine. Okay. Not quite how I thought that would work, but maybe we need to actually do an offset on you. Nice, nice. Okay, okay. So dot y minus 8. Actually, I don't think we even need the typecast here anymore because we're not doing a division where floating precision will be an issue. What? Oh, because I edited the wrong one. Yeah, so 16 is still a little off. So let's try 8 then, maybe? I feel like at this point we're dealing with magic numbers, but... Yeah, okay. That's a bit more representative of what I want. Cool. So that's that setup. Which means we need to do the same thing for the player. So back to main. Let's go find where we make our player for the first time. Update player, no? Where do we make our player? Imaged sprite. Load player table, image sprite. Move to... Okay, so we just need to do something here. PD sprite set collisions enabled on our sprite to true, and then PD sprite
Oh, you know, I just realized we can actually define this up here. Const PD rect player collider is 0, 0, Charlie width, Charlie height. And then we can always adjust that as needed. So then we can say PD sprite set collide rect for the sprite to be that of the player collider. Right? Right, I think. That's a little tall, I'm not gonna lie. So maybe let's cut that in half. Make this a float. And then I think I'm just gonna copy this logic again for the Y position. And that should fix the collider on you. Maybe. Maybe. Yeah. I think it's more like 48, though. Could also change this to 3 instead of 2. Yes. We'll keep 2 on you, though, I think. Yeah, we're still going to need to offset this, so I think I'm just going to manually set that to 48 and just pray that that works. No. 40. I feel like we had it right with 48, just maybe this is too big. Maybe just set that to 24. See how that looks. "24 is too big. 48 doesn't look right either. I hate doing magic numbers. How about the meaning of life, the universe, and everything? I'll take it. We may need to trim this, though. Maybe let's try 16 and see how that looks. There's probably a bit more algorithm I could do, but... Okay, that still looks a little bit weird, though. So maybe 44 instead of... Can we make 48 return? Are we gonna get 48? Yeah, that works. I'll take it. Cool. So I guess now... we just need to look and see whether we have to get collide rect, clear collide rect, check collisions, move with collisions. So I think this is what we want. Returns the same value as move with collisions, but doesn't actually move the sprite. The caller is responsible for freeing the returned array. Or do we need to do this? This is getting a little nasty now. Okay. Okay. So let's kind of revisit the tree then, see how we're doing. That's the source code. That is the source code discovery tree. Okay. Placing them sparingly. Done. Collisions we're working on right now. Which means we have yet another layer added to the tree. Love it. Get rid of you. There we go. Okay. So, creating collision Rex for player and palettes. That is not an issue. We just completed that. Right, yeah, I'm imagining it's going to be a bit more involved. Checking the two have collided. And then I guess, like, setting a flag on collision detection. So I'm going to mark that as such. That's going to be later in the to-do. Yeah, this is going to be a little bit on the weird side here. To-do add collision detection code here. So for now, I'm just going to... Let's also create a new branch real quick. Or, nah, we'll commit it to main. Start work on obstacles. Get them to draw on the screen at a fixed position. And include collision Rex for the player and palettes respectively. In the future, collision detection with the collision Rex. Okay, let's get this committed. Ooh, boy. This was not one that I was expecting to fumble into, because this is more of a, how do you do the thing? Well, at least it's not weird seat array isms, right? So, yeah, I don't think we're going to be able to get that done in 5 minutes. Though I imagine we're probably going to have to either look into the material here, because I imagine it's going to be either this one, right, returns a collision response type, used for collisions that should slide over other objects, when the sprite should stop moving as it collides with the other. Collision type overlap, used for collisions in which you want to know about the collision, but it should not impact the movement of the sprite, such as when collecting a coin. Set a callback that returns... Oh, that returns information on what happens when the two collide. Oh, okay. So we actually want that then. Check collisions. So then, what ends up happening here? So I guess we just need to look at this. Moves the given sprite towards taking into account... Okay.
caller is responsible for freeing the returned array here. Note that collisions is a struct, so you should grab a pointer when accessing one. Okay. Sprite other response type overlaps. 1 if the sprite was overlapping the other when the collision started. 0 if it didn't overlap but tunneled through the other. A number between 1 and 0, the difference between original coordinates, normal, touch. Okay, so it looks like we'll have to look at overlaps here to do that. Okay. Okay. Returns an array of all sprites with collision racks containing query sprite. Returns an array of all sprites with collision racks that intersect the width by height rect at x, y. Returns an array of sprites that have collide rect that are currently overlapping the given sprite's collide rect. Len is to set the size of the array. The caller is responsible for freeing the returned array. So it seems there's more than one way that we could go about this. Oh boy. Oh boy, oh boy, oh boy. I thought this would have been a quick one too. Looks like it's a little bit more complicated than that. Lovely. Okay. So, I guess it looks like that for the next stream that we're doing, we're gonna have to figure out collisions. Interesting. Okay. I kind of expected this, but so be it. Well then, I think that's gonna do it for this stream. Yeah. See you next time where we start playing around with collisions. If you are seeing the recording of this on YouTube and you like the content, feel free to like it. I usually stream every Saturday at noon Eastern Standard or 5 UTC. Yeah. So I guess that does it. Take care, everyone.